Howdy. Howdy. How many of you like Japanese cartoons? So we do have a few in the room. Okay, great. So when I was a kid, I really enjoyed watching Japanese cartoons, especially this one called Doraemon. So Doraemon is a robot cat from the 22nd century. So he time traveled all the way from the future to the present time, brought all the future technologies to help children today. I remember there was one episode talking about technology called computer pills. So this kid just attached the computer pills to everything in his room, like the TV, the fridge, even the books. Then all of a sudden, these things became smart. They could talk to each other. They could follow his instruction. So it's an amazing story, right? The end of the story was a totally tragedy, though. First, it was the coffee machine. So the coffee machine was not feeling happy because the kid was assigning too many things for them to do. Then he shared his feeling with his best friend, the TV, the fridge, and a baseball bat. They had a meeting, and they decided to start a rebel movement, to fight for their human rights. So this cartoon was made in the 1960s. At that time, the author thought, oh, this computer pill technology wouldn't be realized until the 22nd century. But only after about 60 years, we have it now. We just gave it a different name, Internet of Things. Internet of Things is a kind of technology that connects all the devices and the things surrounding us, let them exchange information so they can make better decisions for us. According to a survey, by 2020, more than 50 billion devices and things will be connected, forming a huge network of things that will fundamentally change the way we live and work. It's a beautiful dream. But there's just a very tiny problem like always, money. Most of us are still using the old technology appliances, right? So in order to make IoT possible, we have to upgrade them to IoT compatible. And according to a recent research, the average cost for you to upgrade everything in your home can be as high as $30,000 per household, and that's only the cost for hardware. So it's a really large bill. Nobody would like to pay for that. And that's obviously an obstacle in the way towards IoT. So what else can we do? How can we reduce the cost? How can we talk to the things surrounding us in a different way? And my answer is vibration. Everything in our world is vibrating. We just cannot see that. The podium, the chairs, yourself, and even this building, they are vibrating. So things surrounding us are trying so hard to talk to us, and the language they're using is vibration. So that makes me to think, if we can somehow translate their vibration into English, then we can make IoT much cheaper, right? So I would like to share 3 IoT projects I'm currently working on: construction tracking, driving safety, and bridge inspection, all engineering applications. The 2 big questions I would like to ask are, first, what are the things trying so hard to talk to us, to tell us what's going on? And the second, how can we understand them? Story 1, construction. You probably don't know construction is a very important part of our economy, representing about 10% of GDP and 10% of employment. But on the other hand, construction is also one of the most dangerous careers in the world. It is super labor intensive. For a big project, you are expecting more than 1,000 construction workers working at the same time. And because of the complexity and the uniqueness of construction projects, it can be difficult to track what's going on the job site. Like this project on the screen, we cannot deploy cameras to track the construction activities. So at present, we usually just heavily rely on the manual reporting of construction workers. That creates some huge problems about productivity assessment and, more importantly, safety. So what can we do? What are the things trying so hard to tell us what's going on a construction job site? Construction tools. Small tools, such like a power drill, hammer, cutter, chainsaws, are heavily used in construction operations. For one project I was working for, there were more than 3,000 pieces of construction tools being used at the same time. So check this map yourself. And don't worry if you don't recognize the tools on the screen, because I don't know their names either. We just need to understand there are so many tools being used at the same time, forming a huge Facebook social network. And if we can understand what they are talking, then we can understand what's going on the job site. So how can we do that? Vibration. You know, different tools are vibrating in very different ways when you're using them, right? Even for the same tool, like a power drill, when you are drilling wood, concrete, and steel, the vibration patterns can be very different. So in order to identify the difference, we applied a mathematical model. Here, as you can see, X is different frequency level, from 0 Hertz to 5 kHz, and Y is their intensity. If you check the up and down of this graph, it's kind of like a fingerprint. And then we can project the fingerprint to different construction operations. So how can we track the vibration of tools? And we develop a system. This is the sensor we're using. It's very small, but it's super powerful. It can track the 3-direction vibrations at the frequency of 5,000 data points per second. And it's super cheap, only $2. You can buy it from Amazon. And so we just attach this to different construction tools and collected a whole lot of vibrations. The last step is to plot the Facebook social network of construction tools. You know, some tools are always being used for the same operation, some don't. It's kind of like, hey, the power drill, the cutter, and the chainsaw, they are good friends. They always want to go out together, right? But that hammer, he's a weird person. Nobody wants to work with him. So if you check the social network of construction tools, and as well as their individual status, then you can somehow predict what's going on the job site with all the tool vibration. Now imagine, in the future, there will be a huge heat map in front of a product manager, so he can check, oh, what's going on in this area? What's going on in this area? Oh, that construction worker is doing stupid things now. Let me stop him. So vibration is the language of construction tools. The second story is about driving. Let me ask you a question. How many of you have ever driven on a bumpy road before? Great, everybody in the room. So in fact, 22% of the US roads are considered in poor condition. And the cost to fix our problem is estimated to be $170 billion US. Unfortunately, every year, more than 35,000 people die on the US road. And about 14% of the accidents can be tied to the poor road condition. So it's critical and urgent for us to inspect the road damage, right? At this point of time, we are doing that, heavily with a manual process. We send people outside, usually just once a year, ask them to visualize the damage, or we use the very expensive laser scanner to build the 3D models, but very expensive. The frequency of data collection is not satisfactory at all. So what else can we do? What's plan B? What are the things trying so hard to tell us the road condition? Your cars. So you probably have that experience. When you are driving on a bumpy road, your car tends to vibrate badly. But if this is a smooth road, the driving can be really enjoyable, right? So if we can collect the vibration of the cars, then somehow we can predict the road condition. To deploy the sensors on millions of cars can be very costly. So this time we decided to use a really cutting edge and very uncommon technology, your phone. Everybody is carrying phone while driving, right? So you either throw it to the passenger side, put it in your pocket, attach it to the windshield, or are texting while driving, which is totally illegal. So please don't do that. But the phone has really powerful vibration sensor. It can sense the 3-direction vibrations, and then it also has a gyro sensor can correct the pulse of that. So the idea is to develop some free apps and send the app, shared app with millions of US drivers, and ask them to share their data with us. Then we have millions of data collectors every second. So in the future, when you open the Google Map, you will see another layer called driving comfort. and it will highlight all the bumpy roads. Great. In order to test the concept, we have to do some pilot study. Unfortunately, Texas is doing such a great job maintaining its road. We couldn't even find some, enough potholes, so we were so disappointed at Texas. Luckily, we found some really bad roads on campus, so we could do some pilot study now. So we sent out our vehicles, we collected the vibration, and once again, we plotted the fingerprints of the vibrations and tried to link that to different road damages. The result, the preliminary result was surprising. Now we are able to predict 4 types of road damages just based on the vibration of your vehicle. What's next? You have to remember our phones can also communicate with each other, and the vibration sensors can be used to predict if you are switching between 2 lanes or if you are accelerating. So in the future, it can be like this. Hey dude, I'm going to switch lane. And the other car say, okay, I'm going to slow down. So we can exchange the data among all the phones, and all the cars will be connected. It's a really cheap solution to the connected vehicles. So vibration is also the language of your cars. The last story is a very sad story. You probably have learned a recent incident in Florida about the bridge collapse, right? Unfortunately, it was not the first time. Just recently, 2 bridges also collapsed in California. In fact, since the year 2000, 76 bridges collapsed or closed due to structural failure. 52 people got killed, and 186 people got injured. There are more than 600,000 bridges in the US, and it's critical for us to understand their current health condition. So how can we track their health condition? What are the things trying so hard to tell us the health condition of all the bridges? The bridges themselves. Every bridge is vibrating, and their vibration pattern can tell a lot about their current health condition and when they would collapse. It's just the vibration is so tiny, and we cannot visualize that. So working with my colleague from Arizona State University, Dr. Pingbo Tang, we are using cameras to understand the vibration of bridge. We just took a video, that's a regular video, and then we amplify the vibration, the light reflection by 1,000 times. Now you can easily see the vibration of the bridge. It's the heartbeat of this bridge. Then we collect the data and send it to a computer simulation model. Now we're able to predict the health condition, the age of this bridge, and more importantly, when this bridge would collapse. So I have talked about 3 boring engineering problems. You might thinking now, so what? Will that affect my daily life? And my answer is definitely yes. I have done something at my home. I attached the vibration sensors to everything in my home, the fridge, the TV, and even I documented the vibration when I flush my toilet, which I didn't show it here because it's not appropriate for this event. But now my home becomes really smart because it understands what I'm doing. It understands if I want to turn on the TV, if I want to just get a beer from my fridge. Okay? It is a really cheap solution. It's kind of like the computer pills. Instead of paying $30,000, I have a really cheap computer pills, just like what you saw in that cartoon. So at the end of my talk, I really want to use the last slide to show my respect to the author of the Japanese cartoon Doraemon, Fujiko Fujio. He was my personal mentor. He was the reason why I decided to do a PhD, because I really wanted to realize his dreams. For over 20 years, he envisioned and created more than 2,000 technologies. Many of these technologies have been realized today, but more are yet to come. Today, I'm still stealing his ideas when I'm writing research proposals. So next time, if you see I'm watching Japanese cartoons in my office, I'm actually doing serious research. Thank you.